Hello everyone, my name is Carolina Garma and this video is my exploratory data analysis tutorial. The main objectives of this tutorial or the EDA are the following. The most important is to find out the insights into a dataset. Another important, for example, is the tier 1, which says extract import variables. This means that you will be able to find or to determine which variables between hundreds of those are the most representative of your dataset. Another important thing and another reason of why we do this is because we want to detect outliers and anomalies. All of this in order to understand and make the first assumptions and hypotheses with a set of information. This diagram represents and helps me a lot to understand the process of data analysis. First of all, you have to well define your problem, the understanding of your problem. After that, you have to collect and prepare the data, that is, clean the data, and only and if and you can continue if and only if you have prepared these steps, and after that you will be able to make an exploratory data analysis, which is the reason of this tutorial. Okay, the exploratory data analysis have two types: the univariate and the multivariate, which, as the word says, the univariate is that you analyze each attribute, and with the multivariate you analyze the relations between those attributes. And there are also two techniques to reach this goal, which are the quantitative methods and the graphic methods. The quantitative ones are the central tendency, the dispersion, the shape, and the hypothesis evaluation. And the graphic methods includes the histogram, the scatter plot, and the box plot. We are going to see these three. Okay, for this tutorial, I use the iris dataset, which is included in this link. I attach it in the video description, and it's one of the most important and most useful datasets which you can use to start practicing your skills. And you can see in the chart the dataset characteristics, which are multivariate, the attribute characteristics that are real numbers, and the associated task is the principal skill that you will develop if you work with this dataset. And the number of instance is the numbers of samples that you take. In this case, 150 samples of flower measures were taken, and there are 4 attributes for each measure and another things like the date and so on. Okay, let's start with the tutorial. First of all, I use Jupyter Notebook for this, and you can see the file in my GitHub, which is also attached in the video description. Okay, the first one thing that we must do is import the libraries. Okay, we are going to use 5 libraries. The first one and the second one are used to read the dataset. The following are used to make the graphics. Okay, and after that we load the iris dataset, which is the one I showed in the slides before. So how do we do that? We create a variable with the name iris or whatever, and you make this command load iris. And when you charge the variable, you are going to receive an output like the one in the image, which is a dictionary format. which contains an array with the values for each row and another descriptions like the target description, the names of the columns, etc. Okay, after that we design the column names. How do we that? In the dictionary that we received before, there is a key value which has the name feature names, and inside there are the 4 columns that we are going to be using. For the columns, we need to um, convert the data frame. How do we do that? First of all, we accede to the iris data column, and for the name of the columns, we accede to the iris feature names, where is the names of each column contained. And after that, you put the command head, and you are going to see the first 5 values of the dataset, which now with the columns. And after that, we are going to add a special column at the end, which is to be the name of the species of each flower. Actually, this dataset contains 3 main species, which are Setosa, versicolor, and virginica. Setosa is 0, versicolor is 1, and virginica is 2, and so on. Okay. To add the target, we use accede again to the iris, but now to the column target, and we do again the hit command, and we are going to see now the species column. After that, we prefer the names instead the numbers. So how do we transform the numbers to names? Which those functions. There are 2 options. You can define a classic function like the first one, or a lambda function which is shorter and does the same. So you apply to the species column the flowers function, and again you put the head command, and now you have the column species with the names instead of numbers. And here is when we start doing the analysis. The univariate analysis are the measures of dispersion, central tendency, etc. So first of all, we can find the shape of the whole dataset, and when with the command shape, and you receive as output the number of rows, 150, and the number of columns, 5. After that, we can make the following command, which is described, and it's going to show a table with the number of instance, the mean of each column, standard deviation, quartiles, minimum and maximum values, the basic. We can continue with univariate analysis. We can see the data info storage, which is very similar to the previous. We can find also the null values with the command isNull and the sum. In this dataset, we have 0 null values, which is very, very good. And in the real life, this not often happens, but we don't care. And we can also do the value counts, and we can see that Setosa, versicolor, and virginica have the same number of rows, which is a balanced dataset, and this is also good. After that, we can start with the graphic analysis. The first one is an histogram, which helps us to see the frequency of the variables, and the box plot, which shows us the mean values, the quartiles, etc. And we can do these plots with the library matplotlib and using the code that you see. Another important library for graphics is the Seaborn, and those graphics help us to compare data. Each color represents an species, and you can see very easy the difference between intervals. Actually, the fourth one and the second one are very illustrative and help us to classify each species to a specific interval because each color is most is abarks a specific interval. We can make a group by method, which also shows us graphics to compare. Each color represents one column for each species. And to the multivariable analysis, the most important thing is to find correlations. And Python has a library um, when you can use with a simple command, which is dot correlation, and you can see a heat map with the correlation. The blue ones correspond to a positive correlation, and the red ones to a negative. And what we're looking here is values closer to 1. And actually you can see that petal length versus petal width has a correlation of 0.96, which is very good. And you have find one of the most important correlation of the dataset, which will help you to your to your classification task. And another important thing with Seaborn is the pair plot, which is similar to the heat map, but instead to show you colors, and Seaborn show you dots and graphics. And as you can see in the ones with the arrows, and are the most representative because the data, each color is well defined to a specific interval. And you can see also the graphics that we done before. And that's all for the tutorial. It's a really brief description of what is a EDA, of what a EDA is, and my reference, and that's all. Thanks.